Now, dear children, we go to the next transition in that occurs even in hydrogen atom, which is called absorption transition of what atom? Hydrogen atom. Normally, if I tell you, normally all atoms remain in their lowest energy level. Lowest energy what? Level. But when we pass a white light through a tube filled with hydrogen, okay, then the hydrogen atom absorbs photons. Photon means the energy, okay, of appropriate energy and rise to the various energy level. And this transition, okay, can be shown with the help of diagram. So I am going to show with the help of diagram. But all these transition are nothing but the transition which is observed from the lowest energy state to the higher energy state. That means in case of hydrogen atom, usually as I said, all atoms are normal in the which state? Lowest energy state. And the lowest energy state in the hydrogen atom is basically also called what? Ground state. So that when atom of hydrogen absorb energy, appropriate energy from outside, okay, then the electron, so listen carefully, the electron usually goes from lower energy state to the higher energy state. And when electron goes from lower energy state to higher energy state, at that time the atom always in excited state. And under this excited state of atom, okay, so there is a absorption of emitted radiation, absorption of radiation takes place, okay, and energy takes place, and this absorption of energy makes the electron to go from any of the lower state to the higher state. And basically, and this transition is called absorption transition. But for normal hydrogen atom, when it acquire energy, okay, not to a very large extent, okay, and if that atom is a normal state, okay, then the absorption transition of hydrogen atom usually takes place only in the series, and this series is called Lyman series. So children, listen this part carefully. When we talk about the absorption transition of hydrogen atom, we cannot observe all the series like we observe in case of the emission radiation of what? Hydrogen spectrum. Like it will not be like Balmer series, like Parsons series, it will not be like Batchet series, like Pfund series, like that. So it will observe normally as the Lyman series. Okay, Lyman series means the electron jump goes from what? First orbit to the higher orbits. Okay, and this can be observed with the help of diagram. So for that, let me just show you with the help of diagram. So I am drawing a line, straight line, and this line I mark with n equals to 1. This means the ground state of hydrogen atom. When n equals to 1 means the energy acquired by the electron is in which state? Normal in the what state? Ground state. Now, but when atom receive energy at ordinary temperature, then the electron jump from which state? Go from ground state, that is 1 to second state. So when electron goes from 1 to second state, okay, then there is the absorption of radiation takes place. That means when hydrogen atom absorb appropriate energy from outside, then electron from the lower state goes to the higher state. But normally in which state the electron lies in which state? The ground state, and that electron have a possibility to go from ground state, that is 1 to second state, second orbit. Similarly, the electron may go from what? First orbit to what orbit? Second orbit. Third orbit, so n equals to 3. Similarly, when the electron may goes from what? First orbit to which orbit? Fourth orbit, n equals to 4. Similarly, electron may go from what? First orbit to which orbit? The fifth orbit. Okay, so in this way, the electron keep on going, can go from first orbit to any of the higher orbit. So this can be of infinite extent. So I am just drawing this way. This can be up to what orbit? Infinite orbit. That means electron can go from first orbit to even to the what orbit? Infinite orbit. But you know that when electron goes from any of the lower orbit to higher orbit, the electron cannot stay in that higher orbit for a long time because the lifetime of that electron is very small. So what happened again? The electron return back from that higher orbit to any of the lower orbit. And when electrons return back from any of the higher orbit to lower orbit, and in that case there is an emission of what happened? Radiation takes place. But as for the transition of hydrogen atom is concerned, we are dealing with absorption transition. That's why for normal hydrogen atom at ordinary temperature, only the Lyman series is observed, and this is actually called what series? Lyman series. So absorption, transition of hydrogen atom at an ordinary temperature, basically observed with what series? Lyman series. Okay, only observed with what series? Lyman series. Therefore, at ordinary temperature, as I said, okay, almost all the atom of hydrogen remain in their lowest energy state when n equals to 1, and can absorb energy, appropriate energy, and can have a transition from this lower energy state to the what? Higher energy state. Okay, that's why at ordinary temperature only Lyman series, as I said, is found in the absorption spectrum of hydrogen atom. Absorption spectrum what atom? Hydrogen atom. Whereas in the emission spectrum, as we saw in the last YouTube video, all the series are formed. All the series are formed. But children, you know that hydrogen atom are also present in the sun, because sun is a glowing mass of gas, mostly of hydrogen, helium gas and all. Okay, and usually what type of reaction takes place in the sun? Fusion reaction. Okay, now hydrogen atom, as I said, present in the sun. That's why the hydrogen spectral series are found also in the solar spectrum. That's why the absorption spectrum, absorption spectrum of sun, that means the absorption spectrum hydrogen atom in sun can not only with Lyman series, it can also absorb with what? Balmer series, because the sun acquire a very high energy. That means the gas, the hydrogen gas, basically are in the what state? Ionized state, and acquire a very, very high temperature. Under that temperature, a very high temperature, okay, so not only the Lyman series can absorb in sun, it can absorb with the what series? Next series, that is called what series? Balmer series. That's why in sun, as I said, the hydrogen atom are already in the ionized state. Okay, that's why the electron in the hydrogen atom in the sun is all not only remain in the what state? Lowest state or ground state. The electron may already in the next higher state. Okay, next energy state. That's why the Balmer series can also be observed in sun. Okay, when the hydrogen atom are usually in what state? Ionized, already in what state? Ionized state. So these are the absorption transition under what spectrum of what atom? Sorry, hydrogen atom. But as for the spectrum is concerned, okay, and the emission of radiation is concerned, okay, so Niels Bohr, who proposed the theory, who made the theory of an atom, but as I said, his theory of atom is not applicable for all the atoms. That means there are some limitations that can also observe in Bohr's theory. Now we are going to discuss in detail about the limitation of Bohr's theory. And the limitation of Bohr's theory that we discuss in the next YouTube video.